Hello, you guys. Welcome to today's lesson on graphing using a table of values. Before we get started, if you want to print out your note guide, go to Unit 3, Linear Relationships, and then go to Graphing Using a Table of Values, and you will see that there is a note guide there for you. So go ahead and print that out, and you can use that to help you take your notes as you follow along with this lesson. If you are unable to print the note guide, that's okay. You can still do your notes on a piece of paper, but either way, make sure you either have your note guide out or a piece of paper and that you have something to write with along with a calculator. You're going to need a calculator today, so make sure you have all three of those things, and let's go ahead and get started with today's lesson. So today's lesson is graphing using a table of values. And the very first thing I want to do with you is to review the definition of a line. As part of your notes, you've already written this before, but some things that you need to know about lines. A line is straight. It has no curves. A line extends forever in both directions. Because the line extends forever in both directions, it is made up of an infinite amount of points. In order to graph a line, we need to know at least 2 points that the line passes through. Every line has a specific equation, and the ordered pair for each point on the line satisfies the equation of the line. Okay, and we are going to talk about this one right here today. The ordered pair for each point on the line satisfies the equation of the line. Okay, so what that means, and this is going to go under solution on your notes. So what this means is that when you plug the x coordinate of the ordered pair and the y coordinate of the ordered pair in for the x and the y in the equation will be true. Okay, so that means that the ordered pair provides a solution for the equation. So we know that ordered pairs are listed x first and then the y. So if we have an equation, y equals 2x plus 2, for example, this is an equation of a line, and we know a point on that line is 1, 4. When we plug 1 in for the x and 4 in for the y, in this equation, it's going to make the equation true. So instead of this y, if I plug in 4, and instead of this x, right now we have 2 times x plus 2. So if I plug in a 1 instead of that x, I'm going to have 2 times 1 plus 2. And 2 times 1 is 2. 2 plus 2 is 4. 4 does equal 4. Okay, so this point right here, 1, 4, is on this line. And you can see that if we plug the x in for the x in our equation, and if we plug the y in for the y in our equation, that it did make the equation true. Okay, so that's what it means to be a solution. So let's go ahead and look at an example here. You can see that to the right, I have the line y equals 4x minus 2 graphed. Okay, so this is the graph of the line y equals 4x minus 2. So the equation for this line is y equals 4x minus 2. And every line we can draw in the coordinate plane has a specific and a unique equation for that line. Okay, so that's an important thing to realize, that this line right here is this line right here. Okay, so the equation for this line is y equals 4x minus 2. And you can see that this line is made up of an infinite amount of points. And I've just picked some points on this line, point A, point B, point C. And the first thing I want us to do is list the ordered pair for each point. So the ordered pair for point A, remember ordered pairs are listed x first and then the y. Okay, so if we're going to find the location for point A from the origin, we have to move to the right 1. So that means our x-coordinate is going to be 1. And then we have to move up 2. So our y-coordinate is going to be 2. So point A is found at 1, 2. Remember, you always have to list the x-coordinate first and then the y. Remember, it's in alphabetical order. Okay, let's go ahead and list the ordered pair for point B. Well, from the origin, to get to point B, we're going to have to move to the right 2. So that means our x-coordinate is 2. Remember, our x-coordinate tells us how many we're going to move to the right or to the left. Okay, so we have to move to the right 2, and then we have to move up 1, 2, 3, 4, 5, 6. So 2, 6. That will be our ordered pair for point B. Okay, that's the location of point B. Point C, okay, we can see point C is actually on our y-axis, isn't it? So to get to point C, we don't move to the right or the left at all. So the x-coordinate would be 0. It's right on the y-axis. And then we have to move down 2. Okay, so 0, negative 2. So to the right or left 0, and then down 2. So point C is at 0, negative 2. And then we have point D here. Point D is just all off on its own. Point D is not on this line. Okay, it's important to realize that point D is not on the line y equals 4x minus 2. And the ordered pair for point D, or the location of that point, is to the right 6, up or down 4. Okay, now in the beginning, I talked to you about the fact that when you plug the x-coordinate of the ordered pair and the y-coordinate of the ordered pair in for the x and the y in the equation will be true. So let's check that with the information that we have. Okay, so for point A, I've left some blank spaces here for our equation. Okay, so you can see that whatever our y is in our ordered pair, that's going to go in this place. Whatever our x is in our ordered pair, that's going to go in this space. Okay, so for point A, we know that point A is on the line y equals 4 times x minus 2. We know that the x-coordinate for point A is 1. So instead of the x in our equation, and I'm going to go ahead and do this in a different color here. Okay, so let's say our x-coordinate is 1. So instead of the x in our equation, we are going to replace that with a 1. And then our y-coordinate of our point is 2. So instead of our y, we're going to plug in 2. Okay, so all I did is I took the equation y equals 4 times x minus 2, and instead of the x, we plugged in the x from our point. Instead of the y, we plugged in the y from our point, or our ordered pair. Now, is this true? Does 2 equal 4 times 1 minus 2? Well, let's figure that out. We know that 4 times 1 is 4, and we're going to have to do that multiplication first. And then we do our subtraction. And 2 is equal to 4 minus 2. I wanted that to be a check mark. Sorry about that. Okay, so we would say, yes, this is a true statement, which means that this point is on this line. Okay, any point that is on this line is going to give us a true statement when we plug it into the equation. Okay, so let's go ahead and look at the next one for point B, 2, 6. Okay, well, instead of our y, instead of our x, we're going to plug in 2, right? So in our equation, instead of the x, we're going to plug in 2. Instead of the y, we're going to plug in 6. And then we want to see if this is a true statement. Does 6 equal 4 times 2 minus 2? Well, if we do the multiplication first, 4 times 2 is 8. 8 minus 2 is 6. 6 does equal 6. So we would say yes. Point B is on the line y equals 4x minus 2. Let's look at point C. And our page is getting a little bit fuzzy here, so I'm going to go ahead and just clear us some space out here. We know that point C was at 0, negative 2. Okay, so we have our equation y equals 4 times x minus 2. If we plug 0, I wanted to do that in red, sorry about that. If we plug 0 in for the x, okay, that's going to go right here. And if we plug negative 2 in for the y, that would go right here. Okay, and now we simplify. 4 times 0, we're going to do that first. So 4 times 0 is 0. 0 minus 2 is negative 2. Negative 2 does equal negative 2. So point C is on the line. Okay, now let's go ahead and look at point D. I'm going to clear some more space here. So we know that point D, the location of point D was to the right 6 and up 4. So if we have our equation y equals 4 times x minus 2, and instead of the x, we plug in the x from our ordered pair. Okay, the x of point D, for the ordered pair is 6. So instead of this x right here, we're going to plug in 6. The y for our ordered pair is 4. So instead of this y, we're going to plug in 4. Now, 4 times 6 is 24. 24 minus 2 is not equal to 4. Point D is not on this line. Okay? And we can see that when we plugged in the ordered pair, the x for the x and the y for the y in this equation, that it didn't make the equation true. So that's the way that you tell if a point is on the line or not. If you can plug in the x value for the x in the equation and the y value for the y coordinate and for the y in the equation, if it makes the equation true, then we know that it's a point on the line. Okay, so let's go ahead and look at this example. Are the following points on the line y equals 2x minus 3? And we just want to say yes or no. And I'm actually going to graph this line for you. And we're going to be learning how to graph in this class a little later in this linear relationship unit. So pretty soon you guys are going to be able to graph these lines just as fast as me. But for now, I'll graph it for you. So this is the graph of the line y equals 2x minus 3. Okay? So this is the line y equals 2x minus 3. The question says, are the following points on the line y equals 2x minus 3? Remember, ordered pairs are listed x first and then the y. So we can look at this graph right here, and we can look at this point and we can say, okay, is the point 2, 1 on the line? Well, if we go to the right 2 and up 1, yeah, we can say yes. Yes, it is. But if you didn't have the graph, another way you can decide if it's on the line is you can plug the x in for the x in your equation, and you can plug the y. Oh, I wanted that to be a different color. Let's make it red. And you can plug the y in for the y in the equation, and if it makes the equation true, we would say it's on the line. Okay, so I've created some spaces here so we can plug in some values. Okay, so instead of the y in our equation, okay, instead of the y in our equation, we are going to plug in 1 because we know the y value of our ordered pair is 1. Instead of the x in our equation, okay, so you can see here's the x in our equation. We have 2 times x minus 3. So instead of the x in our equation, we are going to plug in 2. And now we just need to simplify this. 2 times 2 is 4. 4 minus 3 is equal to 1. So we would say yes. Okay? This point is on this line. Let's look at the next one. I'm going to go ahead and clear off some space here. So is the point 4, negative 2 on the line? Y equals 2 times x minus 3. Well, if we plug negative 2 in for our y and 4 in for our x, we can decide if this point is on the line. Because if this statement is true, then the point is on the line. If this statement is not true, then the point is not on the line. So 2 times 4 is 8. 8 minus 3 is 5. 5 is not equal to negative 2. So we would say no. And if we look at the graph of the line again, sorry, when I cleared the page, it actually cleared that off too. I'm going to graph it for you really quick. Okay, so we can see the point 4, negative 2. If we go to the right, 4, 1, 2, 3, 4, and then down 2, that would be right here. Okay, and that point is not on our line. Okay, let's look at 0, 3. And if we look at this line, it's really easy to see that 0, 3 is not on this line. But if you don't have the graph, another way you can decide if the point is on the line is you can plug the 0 in for the x and the 3 in for the y in your equation, and if it makes the equation true, then it is on the line, and if it doesn't, it doesn't. And we know that 0 minus 3 is negative 3. Negative 3 does not equal 3. So 0, 3 is not on the line. Okay? If we look at 0, negative 3, let's see, if we plug negative 3 in for the y, 0 in for the x, 2 times 0 is 0. 0 minus 3 is negative 3. And negative 3 does equal negative 3. And if we look at our graph, 0, negative 3, we can see that it is on the line. Okay? The next one, negative 1, 5. If we plug negative 1 in for our x and negative 5 in for our y, 2 times negative 1 is negative 2. Negative 2 minus 3 is negative 5. So we would say yes. The point negative 1, negative 5 is on the line. And from the origin, if we go to the left 1 and down 5, we can see that that point is on the line. Okay, for the last one, for the ordered pair, negative 2, 1, if we plug 1 in for the y and negative 2 in for the x, negative 4 minus 3 is negative 7. 1 does not equal negative 7, so we would say no. This one is not on the line. Okay, so if you have the graph of a line, it's really easy to look at the line and to decide whether a point is on that line or not. But if you don't have the graph of the line, all you have to do is take the x of the ordered pair, plug it in for the x in your equation. Take the y of the ordered pair, plug it in for the y in the equation, and if it makes the equation true, then you know that that point is on the line. Okay, so the next thing that we're going to move to is, can you find a point on the line y equals 3x plus 1? How would you do that? How would you find a point on the line y equals 3x plus 1? Okay, well, we know that if a point is on the line, then the ordered pair for that point is going to satisfy the equation. So let's say that I tell you your x value is 1. Okay, if I tell you that the point has an x value of 1, to find the y value when the x value is 1, all we have to do is plug 1 in for the x in our equation, and then we know that y is equal to 3 times 1, which is 3, plus 1, which is 4. So when our x is 1, our y is 4. Let's say I tell you that your x is negative 1. If I tell you that your x is negative 1, we can figure out what the y is if our x is negative 1. All we have to do is plug negative 1 in for x in our equation and then simplify. 3 times negative 1 is negative 3. Negative 3 plus 1 is negative 2. So when our x is negative 1, our y is negative 2. What about if I tell you that your x is negative 4? Can you tell me what the y is if the x is negative 4? Well, yeah, that's easy. All we have to do is plug negative 4 in for the x in the equation, and we can solve for the y. Negative 3 times negative 4 is negative 12. Negative 12 plus 1 is negative 11. So when we let our x be negative 4, our y equals negative 11. So for each of these examples that I just gave you, can you see that the y is dependent on what we plug in for x? Okay, so when we plugged in 1 for the x, our y was equal to 4. When we plugged in negative 1 for the x, our y was equal to negative 2. When we plugged in negative 4 for the x, our y was equal to negative 11. So our y was always dependent on what we plug in for x. So we can say that y is a function of x, because depending on what we plug in for x, it will determine the y. So this is an important thing to realize right here. The y is a function of x. So the x determines what our y is going to be. So instead of writing y, we can write y as a function of x. Okay? So this right here, this is function notation. And y being a function of x, that means that y or f of x, that's the same thing. Okay, so if you see a y written, or you see it written in function notation as f of x, that's the same thing. Okay, so the next thing we are going to do is we are going to talk about how to create a table of values, how to find points that are on a line if you have that line's equation. Okay, so you can see this right here. f of x equals negative 2x plus 8. This is an equation of a line. Okay, remember f of x is the same thing as a y. So y equals negative 2x plus 8. This is a linear equation. And in order to graph a line, we have to have 2 points that are on the line. And we are going to find those points using a table of values. Okay, so you can see that we have a column of x. This is our all of our domain. And then this is going to be our range right here. And we are going to use this right here, this equation, to help us find some points that are on the line. So let's say we have this equation, y equals negative 2x plus 8. And to fill in this table, we want to know what the y is when the x is negative 4. So we just take this equation and we're going to figure out what the y is when the x is negative 4. So we take the equation, we write it just like it is, but instead of the x, we're going to plug in negative 4, and then we're going to simplify. Now you guys, this is the place where you need to use your calculators. Okay, do not do this without a calculator. So let's multiply first. 2 times negative 4, negative 2 times negative 4 is positive 8. Positive 8 plus positive 8 is 16. So when we let the x be negative 4, the y is 16. Okay, now that actually gives us a point that is on this line. Okay, and for today's lesson, we're just going to work on filling in our table of values. So for the next one, we want to figure out what the y is when the x is negative 2. So if we have this line right here, we're going to take the equation of that line, y equals negative 2x plus 8, and we're going to plug in negative 2 for the x and solve for the y. So we have y equals negative 2 times negative 2 plus 8. So when our x equals negative 2, our y is going to equal negative 2 times negative 2, which is positive 4. Positive 4 plus positive 8 is 12. Okay, and if we plug negative 2 in for the x and 12 in for the y, that will make our equation true. Okay, so that we know this point, negative 2, 12 is on the line. Okay, let's look at the next one. 0 for the x. So y equals negative 2x plus 8. If we plug in 0 for the x and solve for the y, negative 2 times 0 is 0. 0 plus 8 is 8. So when we let our x equal 0, our y equals 8. Okay, let's do the next two. 3 and 5. So when we let our x be 3, our y is going to equal negative 2 times 3 plus 8. Negative 2 times 3 is negative 6. Negative 6 plus 8 is 2. Okay, so when we let our x equal 3, our y equals 2. And when we let our x equals 5, to figure out what the y is, we're going to plug the 5 in for the x. In this equation, we write it just like it is, but instead of the x, we plug in 5. Negative 2 times 5 is negative 10. Negative 10 plus 8 is negative 2. Y does equal negative 2. Okay, so you guys just created your first table of values. So let's look at one more example of this, and then I want to have you do one on your own for your quiz. Okay, so we have a line here, y equals 6 minus 3x, and we're going to fill in this table of values. We want to figure out what the y value is when the x value is negative 4. So remember, having an f of x or having a y, that's exactly the same thing. This is just function notation, okay? Because remember, this y is dependent on whatever we plug in for x. So these are going to be our inputs, and these are going to be our outputs. That's another way to think about this, okay? So the x values are what we're plugging in. The y values is what we get after we plug the x values in. So if we have the equation y equals 6 minus 3x, and we have negative 4, if we plug negative 4 in for the x, that'll give us 6 minus 3 times negative 4. Our y is going to be equal to, be very careful here. Make sure you're using your calculator. If you have a negative 3 in front of your parentheses, when you multiply it by the negative 4, a negative 3 times a negative 4 is going to give you a positive 12. And 6 plus 12 is 18. So the mistake that lots of kids make on this is not in understanding what they need to do, but it is in the calculations, the plugging in of the values. Okay, so please use a calculator on that part. If we want to figure out what y is, and we know that the x is negative 3, we take our equation, we write it just like it is, but instead of the x, we plug in negative 3. Now, when we simplify this, remember we need to do our multiplication first. So we have to do this negative 3 times negative 3 first. That's going to give us a positive 9. And 6 plus 9 is 15. So when our x value is negative 3, our y value is 15. When our x value is 0, our y value is going to be 6 minus 3 times 0. Negative 3 times 0 is 0. 6 plus 0 is 6. So 0, 6. That would be our ordered pair. Okay, let's do the last two. When our x value is 2, so we take and write our equation just like it is, except for we let our x value be 2. Negative 3 times 2 is a negative 6. 6 minus 6 is 0. So 2, 0. That is a point on this line. 0, 6. That is a point on this line. Negative 3, 15. That is a point on this line. Negative 4, 18. That is a point on this line. Okay? So I'm not going to do the 5. Instead, this video is about 10 minutes longer than I like it to be, so I apologize that this one is so long. This is a little bit more of a difficult concept to understand. So if you are still struggling with this, please, please, please make sure that you come to class tomorrow. We're going to work on this some more. Or make sure you attend Math Lab. Math Lab is every day, Tuesday, Wednesday, and Thursday from 3 o'clock to 5 o'clock. And Miss Kohler and I would love to help you with understanding this better. So for your quiz, you are going to complete the function table. This right here is a function table. Okay? This is our function. And remember that f of x is the same thing as y. So what you are doing is you are finding some points on this line. Now there's one thing I want to caution you on, and I'm going to actually help you with the first one. In order to find the y coordinate when the x coordinate is -2. When you plug this in, be very careful. Do you guys see this minus sign in front of this x? Okay, so you have to have the minus sign, and then the x value is a -2. Okay, so anytime you have two negatives right in a row, that's actually going to be a positive. Or another way to think about it is if you put your x value in parentheses like this, you would know that you need to distribute that negative to the -2. But either way, you get +2 minus 3 for your y value on the first one. Okay, so you're going to set up a function table, complete the function table, and then I actually want you to graph it. So after you find some points that are on the line, so this one would be -1. So we would go to -2, -1, so that's to left 2, down 1. We're going to plot the point. So I want you to plot the points and then graph your line, and then turn this into the assignment box. Like I said, if this is something that is still confusing to you, don't worry, it's okay. It's a tricky lesson. Come to Math Lab. Come get some help. Ask for some help in class. Miss Kohler and I totally want you to be successful at this, and we'll see you soon.